So you're going to find in calculus a whole bunch of theorems, and this is the first of which, that just say existence. So all they're going to do is tell us that there's a point that exists that fits a certain criteria. And it doesn't tell us anything about how to find those points. We have to use other algebra or other calculus to do it. But just knowing something exists makes it possible for us to either persevere when it's hard to find, or if we know it doesn't exist, to not even waste our time trying to find it. So existence theories are important in calculus to lead us toward solving big problems. And the first of them, the intermediate value theorem, is a very specific existence theory that talks about the the range, and what you can predict or say about the domain. So it sort of works in backward order. So let's parse it out here. If f is a continuous function on the interval AB, and notice brackets say it's a closed interval AB, and that's what we have here on the closed interval AB. If f is continuous, and we have been proving that things are continuous now for a little while, and this is why. Once we know it's continuous, we can begin to make assumptions about it. Before that, we can't say anything because we don't really know. So if f is a continuous function on the interval, closed interval AB, and n is any number in the range that falls between f of a and f of b. So it can be any number that falls between f of a and f of b, okay, and it exists. So we're talking about all the n values, or all the output values between f of a and f of b, where f of a does not equal f of b, and that has to be said, because if f of a does equal f of b, then there's no number in between, and we wouldn't have anything to do here. Then there is a number c in the domain in the open interval, right? Open interval such that the f of c equals n. So let's talk about this last part a little bit. The reason the interval has to be open is we're not looking for an endpoint because we already know the endpoints, right? We're looking for c values that point or map to n values on the range. So if we exclude using a and b, then we'll exclude getting f of a and f of b in the set we're evaluating. We can talk about every other point in that interval. That means that if that's true, we can be confident that the element in the domain that maps to n actually is between a and b, and that's going to be important information for us, that we know it falls between a and b. So let's look at a specific example. We have already sort of been using the intermediate value theorem because the logic is there. You would naturally assume this to be true, but it's really the intermediate value theorem that lets us do it. Remember when we were looking at graphs and talking about where roots exist? So I know on this graph I've just sketched in that this is a root, this is a root, and this is a root. But let's look at just part of this graph. Let's make it a little bit bigger. So let's look only at, say, this interval right here. All right, so we've done the continuity, and we know that this point exists, that the f of b equals the f of b, and that the other endpoint on this interval, the f of a, equals the f of a. And what we want to know is there a root on this interval? And in fact, we can see it by looking at the graph that it's right here. But the question is there a root if we're not looking at the graph? Well, we know that the f of b is positive, and we know that the f of a is negative. And so if the output values on the interval between a and b, f of a and f of b, go from being positive to negative, then we know that somewhere on the interval between a and B, there has to be a root. There has to be an x value that gives us a 0 for y. I think that's pretty cool. Primarily because I can be a little bit lazy. You know, mathy people tend to be kind of lazy. If I have a way to find out instantaneously whether or not there is a root, then I'm not going to waste any time trying to factor and use formulas and figure out what it is. If I don't know it's there, I'm not even going to look for it. So it's a pretty handy thing to be able to save us some time and energy. So let's do an example of another way that we can use the intermediate value theorem. For a function, in this case f of x equals x squared plus x minus 1. We want to know if there is a, how do I say this, on the interval. So if I were to graph this between 0 and 5, on that interval, is the output of 11 on that interval. So whatever's happening to the curve between 0 and 5, and we don't know what it is it down here where there's no output of 11? Is it right here where there would be an output of 11? What is it? So first we want to see if we would even get if it's even possible to get an output of 11. And that's straightforward. I'm going to put in the f of 0 equals 0 squared plus 0 minus 1. So that equals negative 1. And then the f of 5, so that's the f of a, and the f of now b, is 5 squared plus 5 minus 1. Well, that equals 25 plus 5 is 30. Take away 1 equals 29. And so on the interval, on the open interval between negative 1 and 29, I can say definitively in there's an 11 value. That means I know that between 0 and 5, because of the intermediate value theorem, that the value that points toward 11, or the input value on the domain, falls between 0 and 5. And now we want to go find it. Well, that's easy enough, because that would be a case where the f of x, or the f of some value c, let's go ahead and put in c, equals c squared plus c minus 1, and that we want that to actually equal 11. So this is just algebra 2 at this point. Minus 12 equals 0, so we're looking for c, what would that be, plus 4, and c minus 3 equals 0. And so our c values are negative 4 and positive 3. Now, which one are we looking for? This negative 4 falls way over here, so this is not what we're looking for. The c we're actually looking for is c equals 3, which maps to 11. Done. And even though this was relatively simple to do, you can imagine functions where that's not simple to do, and it was handy to know that I even could find anything, that there was something there to even look for. So that's the intermediate value theorem in a nutshell. It's the first of the existence theorems that we will explore throughout this semester or through this school year. And I'd like you to practice a couple of these from your textbook. So if you go to page 81, I'd like you to do 84 and 86.